So in this video, I'm going to go over the Fall 2019 Semester Final Exam Review. Just going to kind of talk y'all through these problems for the sake of time because it's 59 problems. So on number 1, if we solve for x, notice here that we have a line. And because we have that line and these two angles are a linear pair, that means we're going to add the 2x plus 10 to the 4x plus 20 and set that equal to 180 because a line measures 180. We'll solve for our x that way. Same way on this other side over here where we have the two y's. We're going to add those two together and set them equal to 180 because again the measure of a line is 180. So that's number 1. Number 2 says find the given measures. In this one we have the segment addition postulate. So we notice here that we're going to add KL to LM and it's going to give us the whole thing. So we're doing KL plus LM is equal to KM. So again, I'm just adding together those two equations, x plus 0.5 plus 3x minus 2, and setting that equal to the 3x plus 1.5. Solving for my value of x, and recall that oftentimes on a test like this, that value for x, that 3 will be one of your answer choices. But that's not the answer. We're looking for LM, KL, and KM, so we have to put that 3 back in the equation. Number 3 says Q is the midpoint of PR, PQ is 2Z, PR is 8Z minus 12. So on this one, notice that because Q is the midpoint, this is our Q right here, of PR, we have those two tick marks on PQ and QR. We have the 2Z over here on PQ, but we could also put 2Z over here between QR because we know those two segments are congruent. So we can add those two Z's together, set that equal to the 8Z minus 12. Again, solve for Z. That would probably be one of your answer choices here. But just make sure you're paying attention to what it says in the problem as to whether you're solving for Z or you're solving for one of the segment lengths. Notice I've written out here, draw and label the leg segment, and then notice that PQ on QR are congruent, thus PQ and QR are equal, so QR is also 2Z. For the next problem, number 4, we're going to draw this again. It says RS bisects QRT. I'm going to pull this up to the top. And so we're going to draw QRT first. We're going to draw this angle here first. Notice that we drew this first. Then we bisected it. That's a key word. We need to notice that when we're doing this problem, because that's what tells us that those arcs are there. Notice the arcs that I have on the two angles. When we have that, that tells us that the angles are congruent. So we're going to set those two equations equal to each other. And then we're going to get x is equal to 2. Again, we have to plug that back into the equation for SRT, which is the 9x minus 4. That gives us 14 for the measure of angle SRT. Number 5 says Z is in the interior of WXY. So WXY is an angle. We're going to draw it, just draw it. And then we're going to label, it says that Z is in the interior. Now, most of y'all probably would have just drawn this like this. And I get that, and that's fine, saying W, X, Y, and then we know that Z's in here somewhere. Again, this drawing is just for the sake of you being able to label it. We could then say this is 110 and this is 20 because those are the measures of those angles, and you should very easily, clearly see that this is the angle addition postulate. So we're going to add the 110 to the 20 to get 130. As you guys are working through this, if you need to pause the video to do some of these drawings, then do that. Number 6, the measure of angle 1 is 8 times the measure of its supplement. Well, because it says supplement, we know that those two angles, when they're added together, have to equal 180 degrees. So I'm going to go ahead and draw a line, and I'm going to draw two angles. It says that one of them's 8x and the other one's x. So then we're going to add those two together. Set them equal to 180, and that we're going to get 20 for x, or the measure of angle 2, and then we're going to put that back in, and that's going to give us 160. For most of you, anytime you can make a drawing, it's going to help you to figure out how to do the problem. So number 7, I would hope all of y'all can do this by now. Obviously, a right angle is equal to 90 degrees, an acute angle is less than 90 degrees, a straight angle is 180 degrees, and an obtuse angle is between 180 and 90. So we're on number 8. So on number 8, it says each angle measure, find each angle measure, justify your answer with a postulate theorem, choose from the following reasons. So if we look at angle 1 up here, it is on the same side of the parallel lines and the same side of the transversal. So that would be 120 degrees, and we should be able to tell that because it's the same, it's an obtuse angle. And because we have two parallel lines here, the only two relationships these angles are going to have are congruent or supplementary. So, and these are corresponding angles. Again, same side of the transversal, same side of the parallel lines. Number 7 down here is a vertical angle to the 120. And number 3 up here is, notice that this one's obtuse, this one's acute. So these have to be supplementary because they're not even the same shape. So these are same side interior angles. They're on the same side of the transversal and inside the parallel lines. Our last one is number 4. This one is also 120 degrees, and that's because they're alternate interior angles to each other. So let's look now at number 9. It says, why is the measure of angle, or why is line M and N perpendicular? That's what that upside down capital T means. So I notice over here that angle 2 is congruent to angle 3. So we're going to work through these statements here. It says, in a plane, if a transversal is perpendicular to one of two parallel lines. Well, I don't see any parallel lines in this drawing, so that's not true. That means that can't be the answer. B, we have highlighted. We know that's the answer, but let's look at why. If two intersecting lines form a linear pair of congruent angles, notice that 2 and 3 are both a linear pair, and they're congruent. So that's the key words here that are going to help me determine that that is the answer to this as to why the lines are perpendicular. Part C says if two parallel lines, again, we don't have two parallel lines, so that can't be the answer. And D says if two coplanar lines are perpendicular to the same line, the two lines are parallel to each other. Again, we don't have any parallel lines to each other, and we don't have two lines that are perpendicular to the same line. So by deductive reasoning, we can conclude that the answer here is B, even if we couldn't figure it out by the fact that the linear pairs of congruent angles produce perpendicular lines. Number 10, these are same side interior angles. And notice that this one's obtuse and this one's acute. And the reason I knew that was because it says here that L is parallel to M. And so then we're going to add those two together and set them equal to 180 to solve for X. If it asked us to solve for one of the angles, we would plug that X back in. So number 11 is a proof. It says, given that lines K and M intersect, prove that angle 1 is congruent to angle 3. So our first statement obviously given. Notice that 1 and 2 are a linear pair and 2 and 3 are a linear pair. And that's the definition of a linear pair, is that those two angles form a line. Then step 3 says 1 and 2 are supplementary and 2 and 3 are supplementary. This is another statement that we know linear pairs are supplementary. Step 4, when we take the supplementary statement and put it into a mathematical statement, that's a definition of supplementary angles. And then notice for step 5, we substituted this 180 for that problem right there because of the other 180s. So that's substitution. And then step 6 from step 5, notice that we subtracted angle 2 from both sides. And then our final step, remember, anytime we go from an equal sign to a congruent sign or from congruent sign to an equal sign, the reason for that is the definition of congruent angles. So for number 12, you guys need to memorize these rules. You need to know them very quickly, easily, clearly, so that you are able to use them whenever you have any questions pertaining to this. Now I'm going to talk y'all through some logic here when it comes to the rotations. So we've got X, Y here. If we start with X, Y here, this would be 90-degree rotation, this would be 180-degree rotation, and this would be 270-degree rotation. So when we're rotating to, over to 90 degrees and 270, our Y and our X are going to be flipped. So both of these are going to be YX. And recall that anything in this quadrant, second quadrant over here, what's in that position is negative, and down here, all the values that will be in the second position are negative. And over here, this is negative x, negative y. And I would recommend that if it's easier for you guys to go ahead and do your grid like this, because remember, a 90-degree rotation about the origin is what? A 270-degree clockwise rotation, right? 180 is 180 either way, and then 90-degree rotation is, 270 is a 90-degree clockwise rotation. Remember, all of our rotations go in the order of the quadrants. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So all of you should be able to see that this is a translation for number 13. And there's a couple ways we can do this. We can add an x and a y to the value and find out where it ends. But we can also count. So if we're looking at our e, going to our e prime, we're going 1, 2 to the left, and then 1 up. So that's going to be x minus 2, y plus 1. You can do it mathematically, or you can do it the way I just showed you. Then number 14 is, it says, find the coordinates of the vertices. Now, the other thing we want to do here is predict where we think something's going to go. So we started out in quadrant 1, and it says it's a reflection over the x-axis, so it should be going to quadrant 4. So when we do this one, our final image should be down here. So we're going to count. So we've got, this was on the x-axis. This was 1, 2, 3, 4. So we're going to go 1, 2, 3, 4 down here. That's going to be our u prime. And then here we're 1 away. So that's going to be our v prime, sorry. So that's our new shape right there. It's a reflection. And 15, it says a 90-degree rotation counterclockwise about the origin. So we take our points, we apply our rule, which is negative yx. And if we plot this, our b prime would be 2, negative 4, which is here. And we're expecting this to go from 2 to 3 to 3 to 4. From 2 to 3 to 3, 4. And then we've got negative 3, negative 4. Which would be right there. That was C prime. Then we got negative 4, negative 2. Right there, which would be D prime. And then E prime is 1, 0. That would be right there. So notice again, it did exactly what we expected, and it went from quadrant 1, or from 2, 3 to 3, 4. And that's what we anticipated it to do. I know my lines are not that straight, y'all, but you get the drift. All right, down here, number 16, it says reflect the figure with the point VWX across the x-axis. When we do that, we would negate the x, and we go ahead and plot those points. And then it says rotate the figure 90 degrees counterclockwise. And we do that, it's going to be negative yx. So ultimately, when we do this, it's going to flip the points, and it's going to change the value of the first point. Actually, both of them are changed, so it's going to be negative x, negative y, ultimately. So, yeah, I was double checking that. So, go ahead and just apply your composition of transformations one after the other and see what you get for each one. They flipped, and the signs changed for them on that last one. So for number 17, it says translate the figure with the points I, J, K, 8 units to the right and 3 units up. State the vector. Well, the vector is going to be those funky looking brackets, 8, 3, because it went 8 to the right and 3 up. And then we're going to add 8 to every x value, and we're going to add 3 to every y value, and that's how we get our I, J, K prime. Number 18 says which sequence of transformations map ABC to RST? So we got to look letter to letter here. So A to R, B to S, C to T. So I notice immediately that if we're talking about A to R, A's here and R's out here. So it's got to be a reflection somewhere in this thing. So if we look at this and I just reflect over the axis here, when I do this, notice that this is my R. This is my T, and this is my S. I can tell that there was a reflection, and then there was a translation. And if we count from S to S, for example, we're going to go 2 to the left. That's going to be X minus 2, right? And then we're going to go down 1, 2, 1, 2, 3, 1, 2, 3, 4, 5. So there's a couple ways you could get this. So now listen, what you guys need to really watch for when you guys are doing this is you're going to have answers to choose from on this test. So you can always work this problem backwards. In other words, test all of the answers and see which one gets you back to the original image. And that's a testing strategy that you may want to use for a question like this on the DA. Number 19 says write a rule using the arrow notation. 5 to the right, the X changes, but the Y doesn't. B is 2 to the left, 1 down. Both of those are going to be negatives. 10 to the right, 5 up. Both of those are going to be positives. And then with D, it says 7 units down. We didn't have any change with the X, but we did have with the Y. We went down, which would be minus. Number 20, a triangle has vertices A, B, C. After the transformation, the image of the triangles has vertices A prime, B prime, and C prime. So an easy way to do this is go ahead and plot the points. You should be able to see this immediately that this is a translation. We can do it manually by counting 1, 2, 3, 4, 5, 6 up, and it didn't move left or right. So there's no X change, but there is a Y change. Again, we went from ABC to ABC on prime. I went backwards, y'all. So this should be 1, 2, 3, 4, 5, 6. So it went 6 down. So X didn't change, but Y did change by subtracting 6. Number 21 says reflect the figure with the points over the line Y is equal to X. Now that rule is, and I don't know where it disappeared to, but it should be here. That rule is, oh, it is there. Sorry. The rule here is YX. That's the rule. And then when we reflect it over the x-axis, we're going to negate the x. So we're going to go ahead and accomplish the first one, and you notice it's in red. Our original's in blue, our new one is in red, and then we're going to actually flip over the x-axis too. So when we do this, our final images are WXY double prime. And we're going to do what is a composition of transformations by applying each of those rules and then getting our answers. Number 22, what we're looking for here are letters to letters. So 22 says complete the congruent statement by naming the corresponding angle or side. So here we have UVW, triangle UVW is congruent to triangle UDC. Well, we notice that V is in the middle and D is in the middle. So that's pretty easy to say which angle is congruent with which angle. For 23, it's IJ. Notice we got IJ right here, which would be IU there. And for the last one, we're going middle, last, first. So we're going to go middle, last, first again in those orders. All right. So number 25 says write a statement that indicates that the triangles in each pair are congruent. So I'm going to go from 1 arc to 2 arcs to 3 arcs. So we got R. Actually, let's just do it in the order it's in. So it's R, S, T, right? So we got R up here, 1 arc, 3 arcs, 2 arcs. So we're going to go 1 arc, 3 arcs to 2 arcs. So just move in the same direction around these triangles when we're trying to write congruent statements. Don't forget that. Number 26 says mark the angles and sides of each pair. So as to indicate that they're congruent. So we got, obviously, we've got V is congruent to D and W is congruent to C. And then we got VU, W and CUD. So we've got our 1 arcs, 2 arcs, 3 arcs again. And then we've got these sides. And again, we can do UV, UD, WV, DC. And then we can go first, last, first, last. So that's the way I would recommend that you work through that kind of problem. Let's now look at this proof. Number 27 says, in this diagram, STU is an isosceles triangle where ST is congruent to UT. The paragraph proof shows that the angle S is congruent to angle U. Fill in the blanks to complete the proof. So it's given, obviously we were given this piece of information right here, that ST is congruent with UT. It says draw TV, so we're going to do that, such that it's bisecting that angle. That's what it says. And I know my drawing's not perfect, but y'all understand. Bisects angle T. And we do that by the definition of an angle bisector, right? So and it says STU is congruent to UTV by the reflexive property. I'm sorry. STU was congruent to UTV because of the angle bisector. Then by the reflexive property, we have that TV, and this was V here, is congruent to TV. Remember, it's one thing to one thing. We're going to talk about that in a second. And then triangle STV is congruent to triangle UTV by side angle side. Notice we got side here, angle there, side. Side, angle, side. And then remember that when we're trying to prove that parts of two triangles that are congruent, we use 3 C's PT. Corresponding parts of congruent triangles are congruent. So let me remind y'all about the reflexive, symmetric, and transitive properties. Reflexive property is the same thing on either side of the equal sign. The symmetric property is two different things switching positions on either side of the equal sign. And the transitive property is 3 things or more. So if I were to say that R is equal to R, angle R is equal to angle R, that is the reflexive property. If I was to say that angle, let me think of the way. So if I were to tell you that R is congruent to S, and then I tell you that S is congruent to R, that is the symmetric property. They flip places. And then when I tell you that angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. That's the transitive property. And the way I tell my students is 1, 2, 3, RST. R is one thing, S is 2 things, T is 3 or more things. Number 28 says, given that L is parallel to N, prove that angle 1, 2, and 3 when added together are 180 degrees. Well, by the way, this is the triangle sum theorem that we are trying to prove here. So first step obviously was given. If you look at 3 and 4 here, 3 and 4, those are alternate interior angles. And 3 and 5, what was I saying, y'all? 3 and 5 are alternate interior angles. 2 and 4 are alternate interior angles. And then when this next statement, anytime we go from an equal sign to a congruence or congruence to equal, that's the definition of congruent angles. Notice then we've got that these 3 angles right up here, when they are added together, they are supplementary. That's the definition of a straight line. And then when we add them all 3 together, we know that that equals 180. That's the angle addition postulate. And then when we do angle 1 plus 2 plus 3 down here, all we did was notice we substituted 2 for 4 because of this statement up here, and we substituted 3 for 5 because of that statement up there. So because we can do that, we can use the substitution property to go ahead and state that the angles inside the triangle, when added together, are 180 degrees. Number 29 says, given CD is perpendicular bisector of AB. That was the given piece of information. And then it says AD is congruent to BD. How do we know that? Because of the definition of perpendicular bisector, and really the definition of a bisector. CD is congruent to CD because of the reflexive property of congruence. And then ADC and BDC are right angles by the definition of perpendicular. So these are both right angles right here. We know that ADC and BDC are congruent because of right angles. All right angles are congruent. And then notice we have here side, angle, side, side, angle, side. So that's why the triangles are congruent. And here again we have that the parts of the triangle are congruent because the triangles are congruent. So that's 3 C's PT. That's corresponding parts of congruent triangles are congruent. With 29, we're given that S and R are congruent and PQ bisects SQR. So S and R are congruent, so I'm going to go ahead and put some arcs here. Then it says PQ bisects SQR. So I think I did this wrong in class for some of y'all, so I'm going to correct it here. This was the angles that were supposed to be congruent. And so our second statement was that SQP is congruent to RQP by the definition of an angle bisector. And then we have this common side to both triangles. That's PQ is congruent to PQ. That's the reflexive property of congruence. Then notice the reason these two triangles are congruent is, again, angle, angle, side. So 31, 32, and 33 have to do with parallelograms. So some of our properties that we should know is that opposite sides in a parallelogram are congruent and that opposite angles in a parallelogram are congruent. So that's the two properties that we're going to use to solve for AD and angle B. Also, I want you guys to recall that when I add angle B plus angle C, that would be 180 degrees because those are supplementary. Consecutive angles are supplementary, okay? And then down here for number 33, it says ABCD is a parallelogram, find AC. Well, the property that we're using on this one is that diagonals bisect each other. So we know that BE is congruent to ED, and we know that AE is congruent with EC. And that's how we're going to solve for our variables here, and then plug them back in to get the answers. So that's how we solve for X and Y. And we could plug X and Y back in and solve for any of the parts that are missing. Then with 34, this is a rectangle. Well, one of the properties about a rectangle is that the diagonals are congruent. So we know that QT is congruent to ST because the diagonals bisect each other, but we also know that these diagonals right here are congruent. So if QT is 36, then this is 36. This one would be 72, but this also would be 72. So recall those properties. So 35 says what values of P and R prove that JKLM is a parallelogram. So again, we're trying to prove that the opposite sides are congruent here. So we would set these equal to each other, solve for the variables, and that is what would prove that this is a parallelogram. And then number 36 says ABCD is a rhombus. Find the measurement of angle AEB. So AEB, it's just find the measurement, sorry. So we're trying to find AD, which is sides. Now remember again here, opposite sides are congruent, right? All four sides actually here are congruent. So if we have two sides, we can find the variable. And then it says that AEB is 15A. So AEB is this angle right here. Remember here that all four of these angles in a rhombus are right angles. Also recall that these angles are congruent. So when we're talking about, let me put a little mark up here. So this angle is congruent with that one. And this angle is congruent with this one. And recall that this would be one arc here too, and these would be two arcs because opposite angles and also alternate interior angles are congruent here, okay? So when we do this one, we can set this equation right here equal to 90 because that's what that angle is inside there. Solve for that variable, and then we can plug that back in down here to get the measure of CDE. So number 38 says trap is an isosceles trapezoid. Find the measure of angle A. So what we should recall here is that P is congruent with A and T is congruent with R. The sum of all those angles has to be 180, but also the angles at T and P, when I add those together, they're supplementary. When I add R to A, it's supplementary. So that's how I can solve for P, and then if I solve for P, then I know what, well, basically, if I can solve for, I know that this one's 115 up here, right? So then when I add those two together, R and A, they have to be 180, so that's how I got A. Number 39, when we talk about this, these 20 over here is a mid-segment. So we're going to add our two bases together. Those are our two bases. Let me do them in a different color so y'all can see. These are our bases, they're in green. We're going to add those two together, and they're going to divide by 2 or multiply by 1/2. And that's how we're going to get our mid-segment. Notice what I did here. So what I would ultimately do here is multiply both sides by 2 to get rid of that 1/2. That's what I did. And then that gives me 40 over on the right. Then I just combine my like terms on the left, get the constant on the right, and then I can actually solve for those two bases, not just x, but the bases. So I could put that 9 back in and solve for the two bases. Let's talk about the properties of a kite. So we know that these angles here are congruent because they're between the non-congruent sides. Notice that our consecutive sides up here are congruent and down here are congruent. The other thing that we need to remember is that the diagonals are perpendicular and that the diagonal between the congruent sides bisects the diagonal that's between the non-congruent sides. So right here, that part, those parts are congruent. Also, I want you guys to recall that all 4 of these are all right angles. So if we're missing a part, we can always solve for another part. So what I did here was I just add, and also remember that when you add all the angles inside any quadrilateral, they're 360 degrees. So that's how we solved. So this one over here would have been 121. And to get this one down here, we would just added the 3 together and subtracted them from 360. Number 41 says, state if the triangles in each pair are similar. If so, state how you know they are similar. So we have to compare some sides here. So I notice I've got a short side here and a short side there. And if we look at LS is right there, and SR is right there, or RS. So that's what we're going to compare. 5 over 10 or 10 over 5, doesn't matter which one we do on the top. And then we're going to see if we get the same ratio. And you guys should see pretty quickly 5 and 10. 5 is half of 10, or 10 is 2 times 5, and 6 and 12. So those do produce the same ratio. And so because we have congruent angles here in our vertical angles, we can say that these two triangles are similar because the side angles side. Then with number 42, we're going to compare each pair of sides. So here we've got a short side congruent, right? 4 and 5, well, I can see immediately that there's no way that these could be similar, because if that's 12 and that's 4, then, and this is 12, then this should be 4, but it's not. So we're not going to get the same ratios either when we do this, because 12 over 4 is 3 over 1, 12 over 5 is 12 over 5, and then 17 over 6 is not even the same as 3 over 1. So there's no way that these two triangles can be similar because they don't produce the same ratio. All right, so now with UTS being similar with UFV, 43, it says find the missing length. So this time we're going to use what we know. We're going to use this statement right here. So we're going to do our US, first last, over UG. See that? And we're going to set that equal to UT over UF. Why are we doing that? Because these are the sides that we have. So we're looking here. See this? FU right there, and TU. See that? And then we've got over here SU. Let me show you again. SU, that'd be first last, and UG. See that right there? So those are the relationships that we're going to use to set up this proportion, and then we're going to solve for UT. So we did US over UG is equal to UT over UF. 63 over 35 is equal to UT over 45. And remember what we do here, we cross multiply these and solve for what's missing. That's how we get that UT is 81. Number 44 says compare the corresponding sides again. So we're solving for the question mark. So here again, we're looking at DE, last two letters, UT, right? DE is here, UT is there. So we're going to put DE over UT, and then we're going to talk about CD here. Notice that, CD, first two letters, K and VU. So that's what we're going to do. So we're going to say DE over UT is equal to CD over VU. We're going to do 9 over 63 is equal to 7 over VU. And again, we're going to cross multiply here. And when we do that, we get that UT is equal to 49. Here again for 45, it says solve for X. And we have the similarity statement. So again, We've got GH, GH here, GH last two letters, QR there. So these are the two sides that correspond. And then we're going to do that over QP, or GP, sorry. GP were our first two letters there, and our first two letters there would be QP. So that's what we're going to do again. So when we do that, again, once again, we're going to cross multiply to solve our problem. And then we can plug that x back in to solve for that side, and x plus 1 is 5. So we could do that if we needed to. 46 says the following are similar right triangles. Solve for x. It says they're similar. So that these are both right triangles, so we can do that for sure. We can even do this because it says they are similar, so the angles are all congruent, right? So we've got a height and a height, right? So that's x over 1.8, and then we've got a base over a base, which would be 4 over 24. Once again, we're going to cross multiply to solve these. This is the triangle proportionality theorem. So initially here we're given that DE is parallel to BC, and it's asking us to prove that AD over DB is equal to EC over AE over EC. So, and if you guys recall when I taught this, if I gave y'all some numbers, if I told y'all this was 2 and 4, and this was 3 and 6, so notice that 2 over 3 is equal to 4 over 6. So we would actually just create a line right there, and you can see that. So here we're talking about ADE and ABC are congruent. ADE, let me go ahead and mark this up here. So it was asking about corresponding angles, right? So we've got this angle is corresponding with that angle. This angle over here is corresponding with that angle right there. Those are the angles we're talking about, step 2. Then we can say these two triangles are congruent, the little triangle and the big triangle, through angle-angle similarity postulate. And actually, they even have a third angle up here because that angle's in both triangles, right? Then we can say the AD over AB is equal to AE over EC because corresponding sides are proportional. So again, we're talking about AD over AB, that's a side of the little triangle over side of the big triangle, side of the little triangle over the side of the big triangle. Then we can say this by the segment addition postulate that AD plus DB is equal to AB. We know that. And then the substitution property for step 6, that's already there for us with 4 and 5. And then step 7 is just us separating those fractions. And notice this right here, AD over AD and AE over AE is 1. Then we can subtract that 1 from both sides, and that's what's going to give us our last step. This is going to give us our proof. This is the triangle proportionality theorem. That's the one that we just proved. So now we're into Unit 6, which is our right triangles. So it says solve for x in the following triangles round to the nearest tenth. With this first one, you should notice immediately that it's an isosceles right triangle. That means these two legs are congruent. Our one and only formula for this, we could use either Pythagorean's theorem here, or we could use the 45, 45, 90 triangle formula, which was h is equal to L square root of 2. And that would be 21 is equal to L square root of 2, which would be our x. We could change that to x. Divide both sides by square root of 2. Hopefully y'all remember this. So this is going to end up being, doing it this way, 21 square root of 2 over 2, which would be the same answers down here. So the question is, this says round to the nearest tenth, and that's why I did it the way I did. But either way, you could do that the way I just showed you as well. But recall that that's a 45, 45, 90 triangle. 49, we're going to use, we're now trying to find x and y. X is an angle. The way we could solve that is that these two angles right here have to add up to be 90 because we've already used 90. So we can subtract 27 from 90 and get 63. Then we can use this 27, or we can use the 63 that we have here to solve for x. We have, this is the hypotenuse because it's opposite the right angle. And then this is the opposite side from the 63-degree angle. So that would be sine, because sine means opposite over hypotenuse. And then we can solve for y by doing the sine of 63 is equal to y over, 18. We can put all that in our calculator, right? So we could actually, in our calculator, just do 18 sine 63, and that's going to give us y. 50, this one we're going to have to use our sides. We could use Pythagorean theorem to solve for y here. Notice what I did. A squared plus b squared equals c squared. And we solved for the y, got 29.9. And then to find the angle, we're going to use an inverse. So if we're trying to find this angle right here, we've got the adjacent side because it's part of that angle, and then we got the hypotenuse. So adjacent to the hypotenuse is cosine, so we do the inverse cosine, second cosine on your calculator, of 14 over 33, and that gives us 64.9 degrees. 51, this is a 30, 60, 90 triangle. I know that because one of the angles is 30, which means this other one has to be 60. And then we have the short side. So our two formulas here are the hypotenuse is 2 times the short side, and our long side is the short side times the square root of 3. So all we have to do is plug the 5 into both of those equations here to get our value for y and x. With number 52, we have to find x. Again, remember that these two angles, when we add them together, have to equal 90. So we simply subtract 14 from 90, that's 76. And to find what we're looking for here, we're going to do the sine of this angle here. That's opposite, right? And this is hypotenuse. And it was the sine of 14. So we did the sine of 14 is equal to 8 over y. And then we can go ahead and solve for y, which would be 33.1. Now we could solve for another value here. Let's say we had z here by doing a squared plus b squared equals c squared. Number 53 is another 30, 60, 90 triangle. And this one again, we have this time the hypotenuse. Well, the formula for the hypotenuse is 2 times the short leg, so we can find the short leg. So we would just divide 10 by 2. So y is equal to 5. And remember that the long leg is just 5 times the square root of 3. Number 54 says find the altitude in an equilateral triangle whose side measure is 8 inches. Altitude means height. That's one of the things you guys need to remember with this one. So when we do this one, we're just looking for the height. So it says an equilateral triangle. An equilateral triangle, all of these angles would have been 60 degrees, right? So when we try to do this height here, we're going to split that in two. So now we have a 30, 60, 90 triangle, right? All of these sides were 8, right? So notice this is the hypotenuse, right? That means this is the short leg. So this answer right here that we're looking for, which is the height, all we have to do is 4 square root of 3. Because it's a 30, 60, 90 triangle, and the long leg in a 30, 60, 90 triangle is the short leg times the square root of 3. So now we're on number 55, and it says find the measure of the diagonal of a square whose side measures 21 meters. Well, there's our side measure, and if this is a square, then both this side and this side are going to be congruent. And so that's going to be the leg of the 45, 45, 90 triangle. The hypotenuse is equal to the leg. We could put an L here, or just a side, times the square root of 2. So this is going to be 21 square root of 2. Number 56 says a bird flies from the ground up to its nest in the tree. The bird flew at a 35-degree angle of elevation, is flying up, right? And it flew 25 feet. How tall is the tree? So we're looking for this height over here, the height of the tree, right? So this time we're looking for this over here. That would be opposite, and there's our hypotenuse. Opposite and hypotenuse would be sine. So the sine of 35 degrees is equal to our variable. We don't know what it is. So I put y up here over 25, which is our hypotenuse. So here again, we could just put this in the calculator by saying 25 sine of 35. So let me show you that here. So we could do it, the other way to do this, again, remember, is that this is the sine of 35 here. We put the 25 there, so we're going to do 25 sine 35 in our calculator. That's going to be our height that we're actually going to solve for. 57 says, given that the sine of A is 7/25, find the cosine of A and the tangent of A. So on this one, I'm going to suggest you guys draw this, okay? So if we say this is A up here, sine means opposite, so that'd be 7/25, the hypotenuse. We could find that third side by doing A squared plus B squared equals C squared. So that means that when we do that, we get that this side is 24 right here. Then we have the cosine of A. If we're talking about A again, that would be then the adjacent side, that's this side here over the hypotenuse. And then tangent would be opposite over adjacent. Our last two problems say solve the triangles. So here we have 2 of 3 sides, so we can use Pythagorean's theorem to solve for the third side. So we do A squared plus B squared equals C squared, again realizing that that's our hypotenuse over there. And that's how we solve for CB. Then if we're trying to find the angles, we're going to have to use a ratio. So to use that ratio, we could say that the inverse cosine, to find angle A up here, the inverse cosine would be what? Cosine is adjacent over hypotenuse, so that's going to be 9/23. And to find B, we could then just subtract this 67 that we already got from 90 to get the 23. We're going to use the same process for the other one over here. And again, we're going to solve for our third side here using A squared plus B squared equals C squared. So that gives us 9 plus 25, that's 34. Take the square root of 34, that gives us 5.8 here. Then when we're trying to find angle R up here, again, we're going to use these two sides. So this is, again, our adjacent side, and this is our opposite side. So we're going to use the inverse tangent of 5/3, and that's 59 degrees. So we know if this is 59 up here, that this one down here is just going to be 59 minus 90 minus 59. So hopefully this video helps. I know I went through it really fast, but something's better than nothing.